Let's now see what that looks like from a more technical standpoint, keeping an eye on the evolution of files inside a project directory and local repo. We start by initializing an empty repo. Notice the .git directory that showed up. And let's look inside and focusing on stuff related to what we covered already. So this whole hooks thing is actually going to pollute my display, and I don't need that right now. So let me just clean that up. Okay, so first there's a head file. Looking inside shows us that it refers to a branch named master, which is what the refs head master tells us. And you can notice on the right that this master file actually does not exist. So what this tells us is, but there's no such branch yet. There's no commit in that branch yet. We are what we call in root commit situation, which is what that ## in my own custom prompt actually tells us. And you can see there's an objects directory as well that has just two subdirectories, two empty subdirectories right now, which are beyond the scope of this video, but you're going to see it populate up real fast. So let's just create a file like echo hi there in hi. You can see that file coming up, but you can see that nothing changes inside the local repo, inside .git. That file is untracked for all intents and purposes. So let's now stage it. And you can see a number of things pop up. First, there is some stuff in objects. You can see that the files are actually split based on the first byte of the object's identity, so the first two hexadecimal digits. And this spreads files out in order to work around the limitation of the NTFS file system regarding the maximum number of files in a single directory. So the identity of a file is actually that first byte encoded in the subdirectory's name, followed by the remaining 19 bytes, hence 38 hexadecimal digits, that are encoded in a file's name. Now, let's look into that file. That's garbage. I can't look at it, and the reason is that it's been compressed using zlib by Git to optimize for space. So we can use a plumbing command to look at this, passing in the identity. So the identity would be 65. So git-conf file-t will look at the type. It will confirm this is actually a blob file, and -p for pretty will print it in a way that makes sense. Right now it's just the plain contents of that file, so we actually do have the contents of that file in there. Also notice that there's an index file that showed up in .git. This is our index, this is our stage, and again, if we attempt to look at it directly, it's garbled, but we can use the git ls files to get a full view of it, ls-file-s, to look at what's in there, and you can see there's a mode, so this is a plain file. It has a given umask 644 rights. Then there's the full SHA for the identity of the blob file, and then there's some extra data and the path, the hi path. So that's my index. That tells me what's in there. Now let's commit the file. Git commit -m initial. Okay, we got a number of new objects showing up, two new objects actually, A443 something and B871 something. And there's a master reference that popped up in the refs heads directory. So if we look at that branch tip for master, it refers to a given object, the B871 something object. It's going to be different on your side if you try this at home, obviously. There's a lot of your contextual info that varies from what I'm recording right now, if only for timestamps. If I look at what that file is, it's a commit. And if I look at what's inside that commit, I see a tree. There's no parent commit because this was the root commit. I see an author with its timestamps. I see a committer with its timestamps. And I see the full commit message. And if I look at that tree, it is indeed a tree object. And if I look inside, I see pretty much exactly what I had in the index, except the index had what we call a stage number, and I don't have any stage number in here. Now, let's say that we create a dev branch, and we make head point to it, so it becomes the active branch. And we can do both in one go using git checkout -b, and you'll see a few things here. First, you'll see that the reference exists in refs heads. It actually has the exact same content. If I display all the files, you see the point to the same commit. Again, I did not create a new commit. Those are just two labels pointing at the same commit right now, which makes sense. But if I look at the head file now, it does reference the dev branch. So dev is my active branch. Now, if we modify our file and we commit it again, we see a number of new objects coming up, as confirmed by looking inside the dev reference. There's a new SHA in there, 942b, which was not known, and that SHA is a new commit. It has a parent commit this time, which was the commit we had earlier, the root commit. This commit has a new tree. And that new tree references a new blob, which is the new snapshot for the file. So in summary, creating a commit that changed our file yielded a new blob, a new tree referencing the blob, and a new commit referencing the tree.